Hi everyone, welcome to discussion in week 9. Today's topic is MOSFET, which corresponds to chapter 11. After the discussion, you will be able to determine the MOSFET's region, which can be cutoff region, triode region, or saturation region. Before we go into that, we need to be clear about the symbols of MOSFET. There are mainly 3 kinds of symbols to represent the MOSFET. A comment here is that we only cover the enhancement mode MOSFET in our class. There are also other types of MOSFET, like the depletion mode MOSFET, but it will not be covered in the discussion. Okay, so let's continue. The most complicated symbol consists of 4 terminals. There are gates, drain, body, and source. We should notice that the symbol for NMOS and PMOS differs from each other in the reference direction of the current ID, as well as the positions of B and S. The second kind of symbol is a simplified version of the first one. You'll notice that the body is connected to the source, and the letter B is omitted in the diagram. The third type of symbol is even simpler. It turns a dashed line into a solid line. It also removes the body parts from the symbol. The tricky part is the direction of the arrow also changes. But keep in mind that they are the same. It will be good to put this in your cheat sheet and make sure you don't make mistakes about symbols in the exam. A caveat here is, in reality, the first and the second kind of symbols have some minor differences. But in this class, we assume that they are the same, in a way that the drain and the source are symmetrical, and the source is defined as a terminal with a lower voltage. If the VDS becomes negative, that means that the original drain becomes a source now. The original source becomes a drain now. And then VDS becomes positive again. Okay, let's continue. After we clarify the symbols of MOSFET, we can talk about how to determine their working regions. The first step is to write down the threshold voltage, VGS, and VDS. The second step is to check if VGS is greater or equal to voltage threshold. If the answer is no, we can say the MOSFET is in a cutoff mode. If the answer is yes, that means the MOSFET is on. Step 3 is to check if VDS greater or equal to 0. If the answer is no, that means we need to change the positions of B and S and then restart from 1. If VDS is bigger or equal to 0, we go to step 4. In step 4, we check if VGS minus V threshold bigger or equals to VDS. If the answer is no, that means that the MOSFET, the NMOS, is in saturation region. If the answer is yes, that means that it is in triode region. Then we are done. For PMOS, the things are a little bit different, because for NMOS, we normally assume that VDS and VGS are positive values. But for PMOS, we assume normally the VDS and VGS as negative values. And all of these inequalities will change. So in step 2, for step 3, and step 4, okay, if we write it down as a table, when VDS is very small, ID approximates to, and the 2 terminals will act like a resistance, which values approximate to VDS over ID, which is 1 over 2K, the subtractions of VGS and the V threshold. Okay, that is the content for today. Hope you enjoy.